Okay, let's get started. So I would like to welcome you guys to WebEdge webinar series. Today's topic is Kafka and KSQL, KSQL along with the Confluent Platform and Kafka, etc. and so on. Okay, so before we continue, I would like to ask you guys to please raise your hand in this Zoom software. This way I'll be able to verify you can hear me. Thank you, appreciate that. Okay, so if you guys have any questions, you can type them in the questions box. I'll most likely answer the questions at the end of the session, but depending on the nature of the question, I might answer it right away as well. But in general, I'll answer the questions at the end of the session. Okay, and then the video recording as well as the slides will be available online. So you'll be able to download these, the slides as well as the audio, the video file later on at the end of the session. Okay, so let's start. So my name is Fahim. I'm with WebEdge Solutions. I'll be covering this particular session. Here we will cover what Kafka is, what's KSQL, and so on. Let me move to my slides here. Okay, so you most likely have received the slides. If you haven't, you will most likely receive the link to the slides later on. So you'll be able to have access to the exact same slides as well as the video recording will be available as well and so on. Okay, so today's agenda is to discuss what's Kafka in case if you are using Kafka already, well and good. If not, we will first of all have a quick conceptual overview of Kafka, just so that everyone is on the same page. After that, we will talk about the streaming aspect of Kafka. Kafka is a very powerful streaming platform, and it can be highly useful, especially when you implement microservices architecture. Although you can use it without microservices architecture as well, but usually you benefit more when you have the microservices architecture in place as well. And we will discuss the streaming aspect of Kafka, and for that we will discuss how we can use KSQL, which is basically a structured query language specifically designed for Kafka. So you can query whatever content you have in your topics and your sort of Kafka queues. They're not called queues in Kafka, they're called topics. So you can query your topics, etc. and so on with ease by using KSQL. And then later on, if we have time, I'll also talk about how we can create custom user-defined functions that are callable from KSQL, etc. and so on. That's the agenda. Okay, so let's get started. And actually, it would be quite helpful if you guys could quickly answer in the chat window if you have used Kafka in the past, or do you guys have any other messaging solution in place, like RabbitMQ or IBM MQ or whatever other solution, messaging solution. Or if you're using Kafka, that's even better. So if you could take a minute and just answer it in the chat window. Okay, sounds good. So most of you guys have some messaging solution in place. Very few of you guys have used Kafka before. Okay, so let's first of all cover what's Kafka in general. After that, we'll discuss the streaming aspect of Kafka. Let me switch back to my slides here. Okay, so Kafka, it's basically highly useful when you have a distributed application sort of architecture. So when you have multiple components, uh, it's a very complex sort of application. Let's say you have some ERP type of application, enterprise resource planning, or some CRM sort of solution, and it has multiple components. Even if you do not have any ERP or CRM sort of solution, that's perfectly fine. As long as you have multiple components and you want to ensure that the components, they are able to send and receive data in a more reliable manner, then for that, Kafka is very useful. So Kafka, in short, it's a pub sub sort of solution. So there will be some publisher and there will be some subscriber, or in other words, we can say there will be some producer or producers, and there will be consumers. And in between, we will have Kafka. So it is like a messaging system basically, but it's more than just a simple messaging system. We will talk about the streaming aspect in detail in just a bit, but just so that everyone is on the same page, Kafka is basically a pub sub uh, sort of solution which allows us to ensure that we can integrate our applications, especially the distributed applications and so on. So it allows us to redirect the messages to a different system uh, and so on, which I'll talk about in detail in just a bit. So Kafka is an open source solution. It's very much similar to any messaging solution, but it's different than messaging solutions. I'll talk about how exactly it's different later on. But in short, overall, it looks like a regular messaging system. Uh, and actually, later on, we'll discuss that it actually looks like a database as well. It looks like a REST API as well. So it looks like lots of things. And it all depends on your goal. Whatever goal you want to achieve, there's a high chance that Kafka can help you in various ways. It can act as a database. It can act as a log aggregation tool. It can act as a streaming solution. It can act as just a regular messaging solution as well, and so on. So it can act as lots of various things, basically. So overall, it is open source. And actually, there is another paid option available as well, which is called Confluent Platform. Confluent Platform is actually available both in open source as well as paid flavors. The paid flavor offers more bells and whistles, which I'll talk about later on. So here we will end up covering Confluent Platform. And what is Confluent Platform? For now, a basic overview of Confluent Platform is that it basically bundles Apache Kafka, and it also contains some other features as well that are more enterprise sort of features, like KSQL is there out of the box. We also have support for versioning or schemas, the structure of our data, etc., and so on. So it contains lots of additional features, which I'll talk about in detail later on. So for now, know that Kafka, overall, it is an open source solution, but you can choose to go for some packaged solution as well, such as Confluent, which is highly recommended if you want to develop enterprise sort of applications and so on. It is possible to just live with the open source flavor. In most cases, yes, it's possible, but in more advanced scenarios, you'll want to go for Confluent Platform. Okay, so it basically lets you integrate various systems. It lets you integrate multiple components, like if you have the ERP sort of solution, sales, marketing, inventory, etc., and so on, they can all be interconnected. You can also integrate it with the other solutions like Apache Hadoop, Apache Spark. You can connect it to, let's say, ELK stack, Elasticsearch, Logstash, Kibana, etc., and so on. Okay, so Kafka is overall like a messaging system, but it's much more than that. And I'll talk about that in detail in just a bit. But before that, let's just cover some of the core concepts. So you will have the producers, and you will have the subscribers or the consumers. And in between, we will have Kafka. And here you will basically store your data. So you will eventually have two systems. You will have a source and you will have a destination. And in between, Kafka will be sitting. And why we need to use Kafka in between, those guys who have used some messaging solution in the past, well and good, you will right away know why we want to involve some messaging solution, which actually includes Kafka as well, in between multiple systems. And actually, to make sense of it, let me give you a very simple example. So say you have a bunch of services. So say you have the front end of your application. It's a simple website. It's the data entry part where you can enter the data, you can view the data, etc., and so on. Say you have order management system sort of scenario. So you have the website, let's say, and then let's say that you also have a bunch of services. They can be SOAP XML sort of services, or these days we prefer using REST APIs mostly. So you can have, let's say, a service for authentication purpose. So you can, let's say, implement OAuth or JWT, etc., and so on, so that whenever any end user tries to connect to the website, it should contact this particular authentication service. A token should be issued to the user, and the user should be allowed to access that particular website uh, for a certain time period and so on. So OAuth, JWT, you can use whatever technique you want, or if nothing else, you can just connect to some simple database and just manage the state in your session, etc., and so on, that the user is logged in and so on. And once the user is logged in, after that, let's say we have the uh, backend of our order management system. So here we have, let's say, orders service. So this website will let us send the data to this order service, and this order service might also want to talk to, let's say, order fulfillment service for shipment, etc., and so on. You might want to have order fulfillment service and so on. So you can have multiple services basically. So right now I have this authentication service, order manage this order service, and order fulfillment service, and I have the front end as well. So in simple scenarios, these systems or sort of components of our overall bigger system, they can contact or send the messages to, or send the requests to each other directly. So you can say that this website is hosted on some web server, like Apache web server or wherever you want. And when the user connects to it, we will talk to this particular authentication service directly. Likewise, after that, we will talk to this orders service. This website will make REST API call to this order service directly. So directly means a request will be sent over, let's say, HTTP protocol along with your data in, let's say, JSON format. You send the data and you expect the response in pretty much real-time manner, or it could take a few seconds or maybe a few minutes. But overall, we are saying that it's a connected system. We are connected to this site. If you lose the connection, uh, you lose that request. Response will not be sent back for that particular uh, request at all. So if you directly connect to some system like this, for simpler scenarios, it's okay, but for complex scenarios where you cannot afford to lose any request at all, or maybe you have network latency sort of issues. You cannot predict how long it will take before the request is received. Uh, Maybe it's not a reliable connection, etc., and so on. So you want to make sure that none of the requests are ever lost, either due to network latency or because of having way too many requests at a given time. So way too many requests. Example of that would be, let's say, Facebook. So Facebook usually receives more than 2.7 billion. Uh, so there are more than 2.7 billion users, registered users, and they send requests and they receive the responses, etc., and so on. So that's insanely huge number of users. So if you have hundreds of thousands of messages that you are sending pretty much each minute, and you need to ensure that none of them are lost, etc., and so on, then in that case, the direct connection will not be recommended at all. The system will be brought down to its knees. So do not directly send the messages or send the requests and then expect the response from a service like this. Instead, we should use some solution in between these. So for example, here we have the website, we have the ordered service, and in between, we should use a solution such as Kafka, or you can use some other messaging solution as well if you want. But here our goal is to discuss Kafka in detail. But when you use some messaging solution in between, such as Kafka or RabbitMQ, etc., and so on, let me actually show you a diagram for that. So here I have a order management system. Here I've involved some other services as well. Okay, so here I have a order service which contains additional sub-services like fraud service, order detail service, inventory service, email service, order shipment service, or fulfillment service, invoice service, and so on. So we have lots of services and they need to talk to each other. So here we have the order service. Ignore the multiple instances of which are showing up here right now. Here we are assuming that we have Docker containers as well. We have multiple containers of the same service, but now ignore Docker altogether. So just say that we have order service here. And this order service needs to talk to some other service, like let's say order detail service. So rather than directly sending a message to this order detail service, in between, we are involving Kafka. The Kafka allows us to create topics. In most messaging solutions, we use the term queues, but here we use the term topic. And a topic can contain multiple items. Each item would be some sort of request. It would be some sort of data either in a simple text format or in JSON format or XML format, or you can use some other format as well. So basically, we store the request in a topic. Why we stored the topic or stored the request in the topic? So that in case if the connection is lost, if you do not have the network connection, maybe the order detail service is currently not contactable, it's down. So we still have the request saved in the topic. And later on, whenever the service becomes available, it can connect to this topic and it can process that request. So this can be very handy when your system might not be available due to network issues and so on, or even if the network connection is there and you're able to connect to the service, we are still choosing to use the topic concept, which is offered by Kafka, so that if it's a very time-consuming sort of operation, it will take several hours or maybe even days. We can still have it stored in this topic, and then the other whatever other services we have, they can receive the topics or items of the topic, and they can fulfill them one at a time, and they will send it back to some other topic. So you'll basically end up having sort of an inbox, and you will end up having an outbox as well. So in the inbox, you receive the requests. In the outbox, whatever, once you have fulfilled the request, you store the response in that outbox. So basically, this way we are loosely coupling these services. They're not tightly connected to each other. They're loosely coupled. They do not need to know the URL, the address, etc., and so on of each other. In between, we are using Kafka. So Kafka is letting us loosely couple these things, which will ensure that we are able to fulfill more requests, even if there are way too many requests at a given time, like several 100,000 requests. You can still save all these requests safely in this persistent storage, which is provided by Kafka, and then you can fulfill them one at a time and so on. So basically, it offers a persistent storage, which is very reliable. It's sort of transactional in nature as well. You will never have partial requests stored. It will be a complete request, or it will be nothing at all. So it improves the reliability. It improves your longevity of the process. Like if it's a very long-running sort of process, it will still work and so on. So basically, quite often we try to involve some messaging sort of solution in between. Kafka is one of the messaging solutions. It's actually much more than that. It's not just a simple messaging solution. It's much more than that. And slowly and gradually, I'll discuss what are the differences between Kafka and some other solution, like let's say RabbitMQ, etc., and so on. So overall, for now, it looks like it is like a regular messaging system. It sits in between multiple systems. And these systems can be any type of systems. They can be database servers, they can be application servers, they can be REST services, etc., and so on. So in between, we have Kafka, and they will be publishers and they will be subscribers. So publishers will send the data to Kafka topic, and subscribers will consume the data which we have in the Kafka topic. And quite often, we usually create two topics, one for input purpose and one for output purpose. Okay, so here we have discussed the basic concept that it sits in between multiple or at least two systems for the sake of loosely coupling the systems and for improving the reliability and longevity, in a sense that even if it's a very long running process, it will span multiple hours or maybe days, it should still work. And in case if one of the publishers or subscribers have gone down, it shouldn't matter. Whenever they are brought up and running, it should still be functional. So Kafka is meant for high throughput. So high throughput means literally hundreds of thousands of requests pretty much each second, not even just per minute, but pretty much every second. Um, it's highly scalable. Scalability is one of the key aspects. Later on, we will talk about Kafka cluster concept. So Kafka can be installed on multiple machines, and that basically ends up creating a cluster. And a cluster is basically composed of at least one machine. Otherwise, you can have multiple machines as well, where we have uh, the broker. I'll talk about broker concept later on. I'll talk about Zookeeper, etc. as well, and so on. But for now, just know that Kafka can be installed on, or set up on multiple machines. So this way, we can make things highly scalable. It's pretty much infinitely scalable. As long as you have more VMs or more resources available, like even if you have Docker containers, you can set up more Docker containers on the same machine or multiple machines, and you can make things more scalable. You can support more users, more requests, improve the longevity, reliability, etc., and so on. And due to replication concept, it ensures that all the Kafka servers, they're also known as brokers, they will be sort of synchronized. They will contain the exact same topics and the same data, etc., and so on. So this way, if one of these machines crashes, you still have the data available somewhere else and so on. So basically, you will end up having any publisher type of application, which could be a website, it could be a desktop application, it could be a cell phone application, it could be a REST API as well. And likewise, you will have a subscriber, which can be the same things as well, like a console application, desktop application, a website, etc., and so on. They can be databases. They can be Apache Hadoop. They can also be Apache Spark, ELK, for the sake of log aggregation, etc., and so on. It's a highly durable, and it supports streaming concept. Streaming wise, if you're those guys who are already familiar with some other messaging solution like RabbitMQ, IBM etc., and so on, usually messaging solutions, they are mostly meant for all the conceptually look exactly what we have discussed so far. We will have a publisher, we will have a queue of messages, and we will have a subscriber. So a publisher will send a message, subscriber will consume this message, and usually we delete the message. Or in most cases, or depending on what messaging solution you're using, the message will be deleted automatically. So our goal is to just receive the message and process it and just delete it right away. Whereas in case of streaming, Kafka is primarily a streaming platform. So it will store the messages, and by default, none of the messages are ever deleted by default. They are kept in the topic. So topic is basically equivalent to queue concept. The messages are kept in the topics, and they're not deleted by default on their own. And what it means is that you can have multiple subscribers. They can receive the same data. So rather than saying that we have just a single subscriber and that subscriber has processed the data and the data is now gone from the topic, no. In case of Kafka, it's by default, it's a streaming platform, which means that you can have multiple subscribers and they can connect to this Kafka topic at any time, at any stage, and they will be able to process the similar data. So the same data can be processed by other clients, regardless of when they connect to it. So by default, Kafka will not delete the topics, but you can choose to use it as a regular messaging solution and configure it in such a way that it should delete the message immediately after it has been processed. Or you can choose to configure the expiration time that after a day, the older messages could be deleted, etc., and so on. The streaming means you keep on sending the publishers, they will keep on sending the data to these Kafka topics, and subscribers will be able to get the data whenever they want. So it will be streamed. They will be running in sort of real time, and they will be able to send and receive the data, and it will be sort of a never-ending process. So unlike databases, where you say select star from this table, It shows you the result, and that's it. It will not show you the up-to-date real-time sort of data unless you run the query again. Whereas here, in case of streaming, when you run the query, later on we'll discuss KSQL, Kafka SQL. When you run the query, it will keep on running in the background. It will keep on showing you the up-to-date data. As soon as you receive it, it will show you the data right away. So it's a streaming sort of concept. And it ensures that it's durable and none of the data is lost. So I'll talk about the streaming aspect in more detail later on when we discuss KSQL. Okay, so Kafka can be used in various ways. Kafka, it actually resembles a REST API. It is not a REST API. It's not a programming technique that replaces REST API, but conceptually it resembles a REST API. How it resembles a REST API? So say you have some SQL Server database or Oracle or MySQL or DB2 or whatever. Then here we have, let's say, Kafka. Then here we have some application which needs to process the data from SQL Server. By default, SQL Server or Oracle, they do not support streaming concept at all. When you run the query, select star from this table, that's it. Whatever data you had, only that will be returned. And unless you run the query again in future manually, it will not show you the new data at all. If you involve Kafka in between, you can choose to convert this SQL Server database or any other database to streaming sort of technology. So here you can use Kafka. Kafka provides various things, which we actually discuss in great detail in the full-blown course, but that's known as Kafka Connect. So Kafka Connect allows us to connect to pretty much any data source. SQL Server, Oracle, Apache Hadoop. You can connect to ELK. You can connect to Apache Spark. Sky's the limit. You can connect to pretty much any system under the sun. There are tons and tons of connectors available, which lets you connect to pretty much any type of data source. So even without writing any line of code, in most cases, you can use Kafka Connect, and you can say that you want to stream this data. As soon as new data becomes available, it will basically keep on streaming it. It will make it available in this Kafka topic, and then your subscriber, any application, a desktop application, a cell phone application, or a web-based application, can get the data of this Kafka in sort of real time. So the moment it becomes available in SQL Server database, due to Kafka, now it will become available to your destination application as well. So basically, Kafka can be used to convert any static sort of data source, like SQL Server is sort of static in the sense that you get what you have only at that point in time. If you want to get real-time data, it's not available out of the box. You just have to keep on running the query manually over and over again to see what new data is there and so on. Whereas here, it's able to convert any system to a streaming sort of a platform or a system. The sky's the limit. You can use any source and any destination. You can use SQL Server, Oracle, ELK, Apache Hadoop, Apache Spark, name it. Most standard applications or servers, etc., and so on. You can find a Kafka connector for them and so on. In more advanced cases, yes, you do have to write lines of code manually. You will have to write the lines of code. Like later on, when I discuss KSQL, you will notice that we are able to connect to any topic and we are able to sort of stream it, etc., and so on. I'll talk about that in just a bit. So coming back to this point here, it resembles a REST API. Why it's resembling a REST API? Because if you guys have used REST APIs, you have called them from jQuery, JavaScript, Angular, etc., and so on. You must have noticed that as a consumer of a REST API, we do not even have to know what language we have used to develop that REST API. Did we use Java? Did we use .NET? We don't care for it. We just need to know HTTP protocol. We need to know get method, post method, put method, delete method, and we just send the JSON data, and we get the result and so on. So likewise, here, due to Kafka, Kafka is sitting in between. And this, let's say, any application written in, let's say, Java, .NET, Node.js, PHP, Python, etc., and so on, is now independent of this technology which we have used on this site. It just needs to know Kafka, that's it. So our application, our destination application, or the consumer just needs to know Kafka, and it will be able to consume the data without even knowing what source we have. So that's why we say that Kafka resembles a REST API, because we do not have to care for the source, what technology we are using on the source side. The destination can consume just by connecting to Kafka. Likewise, the source doesn't have to know what destination we are using. It just has to send the data to Kafka. That's why we say Kafka resembles a REST API sort of concept. It acts as a service bus, or like a messaging solution. So just like we discussed previously, that when you have multiple services, in between you involve Kafka topic, or if you're already using messaging solutions like RabbitMQ, etc., and so on, you save the requests here, and then you process them and so on. So it resembles a service bus or a messaging solution, where you store the data in a sort of a more persistent storage, which is Kafka in this case, and then you process it on the destination side. That resembles a service bus. So rather than sending the data directly to your destination application or the consumer, you send it to Kafka or some other messaging solution so that it can be processed by any destination application in future. That looks like a messaging solution. And it also looks like a database as well, because you can store data in a Kafka topic, just like in any messaging solution. You can store the data in a queue, and you can later on retrieve the data, etc., and so on. So it looks like a database. You can actually choose to use it for the sake of storing any type of data, like even for the sake of storing your logs. You can aggregate all the logs in Kafka without ever using any database whatsoever. You can choose to use it as a database as well if you want. So Kafka is lots of things. But primarily, it is a streaming platform. It lets you stream stuff in pretty much real time. The moment it happens, you receive it. The moment it's there in Kafka, you receive it on the destination side. And it keeps on getting sort of streamed in almost real time. And another major difference compared to some messaging solution would be, in case of other messaging solutions, we often vertically scale the solution. I have some issue with my tablet's driver. Okay, so you can vertically scale the messaging solution. Like you can flesh out the system where you have installed the messaging solution. You can add more RAM, add more processing power, etc., and so on, and so on. Whereas in case of Kafka, it is horizontally scalable. So a cluster can be composed of multiple physical servers, or they can be virtual machines, or they can be Docker containers. They can be running on premises. They can be running on the cloud as well, like Azure, AWS, etc., and so on. You get to add multiple instances running on separate machines. So this way you get to horizontally scale out things. So this way you can improve the reliability, you can increase the number of users that you're able to support at a given time, and so on. So that is another major difference compared to most other messaging solutions, where we usually just vertically flesh it out by adding more RAM, more processing power, and so on. Whereas in case of Kafka, we horizontally scale it out by adding multiple instances running either on multiple machines, or like VMs, or physical machines, or on premises, or on the cloud, etc., and so on. And we have already discussed that it can be very useful in microservices architecture. If you're using microservices architecture, if you're creating multiple small Docker containers where each Docker container hosts some piece of application, like account service could be running in a separate Docker container, product catalog would be running in a separate Docker container, uh, so on and so forth. And in between, you can involve Kafka. So rather than letting these services, like here we have email service, we have inventory service. So rather than letting these talk to each other directly, we can send the request, save the request in our Kafka topic first, so that later on our destination or the consumer or the subscriber should be able to connect to this particular Kafka topic and process the request one at a time and so on. So this way we loosely couple the system. We ensure that the producer and the consumer, they are independent of each other. In between, they just need to have Kafka. Kafka is the only thing that they are depending on. They don't need to know what's the technology used on the destination side and so on. And again, streaming will be available. So these will be able to receive the messages on the consumer side or the subscriber side in almost real time. The moment it shows up in the Kafka topic, it will be available to the subscriber. Then in Kafka, we get to use various terms. Some of them I've already talked about, like we have topic. Or first of all, let's draw a cluster. So cluster is a collection of Kafka instances. You will want to have at least one instance. And each Kafka instance is basically also known as a broker. You can just call it a Kafka server. And actually, later on, I'll talk about Zookeeper as well. That's where broker will, or Zookeeper will start acting as a broker. For now, you can just say that it's sort of an instance of Kafka, but in reality, it's not Kafka by itself. It's some other technology, which I'll talk about in just a bit. It's actually Zookeeper in case of Kafka. So you can have multiple brokers that can be running on separate machines. And each, or all these brokers will be synchronized. They will be replicated. Or you can choose to not synchronize them. You can say that, no, they should be sort of separate instances. Like you want to use one of them for development purpose, one for production purpose, etc., and so on. But you can definitely choose to synchronize these as well for the sake of having better reliability and for supporting more users and so on. So for now, you can think of broker as a Kafka instance. That's the easiest way to understand Kafka for now. But in reality, it's much more than that, which I'll talk about once we discuss Zookeeper. And then here, we get to create topics. Topic is like a queue where you get to store the messages or the requests, etc., and so on. And all these topics, they will be synchronized if you're choosing to synchronize these brokers. And they will be the publishers. Publisher will just need to know, okay, we have some cluster, we have some topic, we want to write a message to a specific topic. And the consumer or the subscriber needs to know the topic name as well. And in between, we have a cluster, which can be composed of multiple instances for the sake of better fault tolerance and so on. The Kafka topic is where you'll end up storing the messages. In more advanced cases, we use some other terms as well, like we use a partition concept. Partition lets you partition your topic. A very simple example would be if you receive order, or let's say a request for orders, you can say that you want to partition them by date. So data that was received in the year 2000 should be stored in a different partition of the same topic. Likewise, for each year, we want to store the data in a different partition of the same topic. This gives us better performance and so on, because we'll have to read less data rather than reading the whole topic. And a producer is any application. It can be, let's say, a web-based application. It can be your front end or the website of the front end of your system, basically. It can be a desktop application, a cell phone application. It can even be a database server. So even database can act as a producer as well. Even though database by default doesn't send out data, it just sits there and you have to get data of it. But in case of Kafka, you can use it as a producer. Like I gave you example of SQL Server, and you can use Kafka Connect, or you can write your custom application which can retrieve the data and stream it, and consumer can get the data of a Kafka topic, and then it can process it and so on. So sky's the limit. You can pick any two systems, database servers, uh, web services, etc., or application servers and so on. They can act as a producer as well as a consumer. And talking about Kafka Broker is actually an instance of Kafka, but we also involve something else on top of the Kafka instance concept, and that is known as Zookeeper. So Zookeeper is an open source software which is required in order to use Kafka. Zookeeper, the easiest way to understand it is it's a coordinator. If you have multiple Kafka instances, where each instance acts as a broker, which offers data in the form of topics and so on. Zookeeper will basically ensure that they're all synchronized, they're all aware of each other. They know who, for the sake of fault tolerance, sort of auto failover and so on, they should know which one is the active server or the broker, which one is synchronized, which is not synchronized due to network issues, etc. and so on. So Zookeeper basically helps in accomplishing these things. It's a coordinator. So Zookeeper is required in order to utilize Kafka. And then overall in your cluster, you will have at least one Zookeeper and you will have multiple brokers for the sake of better fault tolerance. So a cluster is basically composed of at least one Kafka instance. Then we have talked about Zookeeper concept, that it basically coordinates, it helps you ensure that the Kafka instances or the brokers, whatever topics they have, whatever data they have, it's synchronized across all the instances. And like I mentioned previously, Kafka can integrate the systems. Pick any two systems, it can integrate them. It can help you implement streaming concept. So if you just grasp your mind around that database concept, the database is usually static. It just sits there. You have to query it yourself. You have to query it over and over again to see whether you have new data available or not, and so on. So if you use Kafka, it can help you implement streaming concept. It can help you get new data automatically. It can be sent out to your subscribers or your consumers and so on. So it can basically convert any two systems to streaming sort of systems. So pick any source, any destination. The sky's the limit. They can be databases, they can be application servers, web servers, etc., and so on. Quite often, you can just choose to use the out-of-the-box Kafka connector to accomplish it, but in advanced cases, you will have to write code yourself in Java, Node.js. There are several other languages that are supported. Okay. Then let me see if there are messages that are directly related to it. Okay, so there's a question, can one broker have more than one topic? Definitely. And it's actually highly recommended that we should have multiple topics. If nothing else, you'll want to have one topic acting as inbox purpose and second topic acting as the outbox purpose. So in between the multiple systems, let's say we have the website and we have, let's say, the order management system here. So the website wants to send a request to order management system, and in between, you'll want to involve the Kafka topic. So this can be, let's say, your in, so request in, or name it whatever you want, let's say order in, and then this order management system will want to connect to this particular orders in topic, process the request, and once the request has been fulfilled, ideally we should store it in a different topic. We can name it, let's say, a response or orders out. So it can send the response to it. or store the response here, and then the website can basically act as a subscriber in this case and get the data off it. So previously it was acting as a publisher, and this was acting as a subscriber. And then once the response has been sort of calculated, then it will act as a publisher, and this will act as a subscriber. So they can both act as publisher as well as subscriber at the same time. Okay. And then before we discuss the streaming concept in more detail, let me first of all quickly show you a very simple example here where we can see various components, what components we typically have in Kafka in order to make our system work. So for this purpose, I already have this virtual machine running. Let me go to this virtual machine here. Okay, so here I have multiple terminals. I have this web actually. Okay, so it's a very straightforward example. Even in a very straightforward example, you need to have multiple components running that are part of Kafka. In order to make Kafka work, you have to first of all run the broker, or sorry, Zookeeper. The Zookeeper is the coordinator. Even if you have a single Kafka instance or broker running, you still need this coordinator. It's mandatory. And it's definitely, its usage is more obvious once you have multiple brokers or multiple instances, so that it can check whether they're all synchronized, which one is currently acting as the leader. Leader means that's currently the active one. And in case of that machine crashes, or that Kafka instance crash or broker crashes due to whatever reason, maybe the machine has crashed or maybe the software has crashed, it will Zookeeper will automatically decide which other replicated broker it should uh, sort of convert to the active leader and so on. And whenever you fix the damaged broker, whenever it's brought online again, it will get synchronized uh, automatically because of Zookeeper. So Zookeeper is a highly useful piece here. You do not directly interact with it, but you do need to run it. So Zookeeper has to be started. Then here I have the Kafka server, which is basically going to create a broker. It will be a single broker. And when you start up this Kafka instance, it will get connected to this Zookeeper. Zookeeper will start managing it. And you can choose to have multiple Kafka instances or multiple brokers if you want, for the sake of better fault tolerance, for better reliability, and for supporting even more number of users and so on. But for now, I have just a single broker here. And then you need to have a publisher. In this case, my publisher is a Spring Boot application. It can be a simple Java application or a Spring Boot-based framework-based application. It can be a C# application, .NET framework application. It can be a Node.js application. You can use pretty much any major language under the sun that can act as a publisher. So this will basically send messages, write messages to the Kafka topic, which are managed by this Kafka broker. And then we need to have a consumer. Or before that, so I'm running the Spring Boot application here. It's available in this web browser. I'll be able to send or write messages to the Kafka topic by using this particular front end. And then I need to have a consumer. Consumer-wise, you can have a desktop application, a web-based application, a cell phone application. It can even be a database server as well, where you just want to write the messages or the data and so on. So it can be any type of destination. For now, I'm using the out-of-the-box Kafka console consumer, which lets us just look at what messages we have in a topic without writing even a single line of code and so on. But obviously, in the real world, if you have, let's say, order management sort of system, if let's say the front end is going to send a request to ordered service, then order service should act as the consumer. You will have to write the code for it. In the full-blown Kafka course, we cover how to write code in Node.js and Java, etc., and so on. So you can use various technologies and languages. So for now, I'm using just the out-of-the-box console-based consumer, which will show us the messages in real time. The moment they show up in the Kafka topic, the consumer will show you the messages in real time, and it will be streaming sort of concept. The streaming means real, almost real time. The moment it happens in the topic, the consumer will be aware, will become aware of it. It will be able to process the data, etc., and so on. So keeping this in mind that we have a zookeeper, a broker, we have a publisher, and we have a consumer or a subscriber, let's run this particular simple application and see how it looks like. It's very straightforward at this point. Let me first of all run Zookeeper, the coordinator basically. In the full-blown course, we covered how to configure all these things in detail. Right now, I already have things pre-configured. I'm just running the command. So Zookeeper is now up and running. Next, we can start up our broker, the Kafka instance. And in the real world, usually we have multiple Kafka instances or brokers running on multiple machines for the sake of better fault tolerance and so on. Okay, so this one is running. Oh, this one actually, for some reason, failed. Let me double check why. Okay, I think I already have one instance running in the background. Let me just quickly restore my VM instance where I've sort of the blank setup for this one. Or the things are already sort of stopped there. None of the instances are running there and so on. Let me quickly start it up. So let me quickly show you this one. After that, we'll take a short break. After the break, I'll talk about streaming in detail. Then I'll show you how to use KSQL, how to write select sort of statement to query Kafka topics, etc., and so on. Okay, so we have the same setup here. Let me just rearrange these windows. This one is just the front end. We have our did I accidentally minimize it? Move it somewhere. Let me just bring it again. In the meanwhile, let me quickly look at some of the questions as well. Kafka user in microservices. Okay, so regarding microservices or Kafka user in microservices, Kafka can be a good medium to write messages to, but how microservices has to read data from DB related to that microservice? Oh, okay, so very good question. So definitely in case of microservices, most developers or most people usually prefer bundling the database inside the same Docker container where your service is running. So this way, the database is no longer accessible from outside that container. So definitely, it's a valid point. So in that case, you will have to do one of the two things. Either host the database outside that container where your service is running, which you might not want to do because microservices is in favor of having the database running inside the same container where the service is running. The best possible solution would be to expose the functionality of your database as REST APIs. So we should not allow direct access to the database. We should instead utilize REST APIs. So answering the question in more detail, what you'll want to do is, if let's say this is a Docker container, and you have, let's say, some database here. Doesn't matter what database you're using. It could be NoSQL database such as MongoDB or whatever database you want. So definitely you can use pretty much any database here. It can even be SQL Server, which actually runs on pretty much all platforms. It runs on SQL on Windows, it runs on Mac, it runs on Linux as well, because SQL Server is now cross-platform. Or you can think of it as, let's say we have Oracle here. So it doesn't matter what database we have here. And here we have, let's say, the REST service as well. So this REST service will basically want to use Kafka in between, but not here. Kafka is usually not set up inside the same container where we have some other service running. In most cases, Kafka should be running in a totally different container. And this should be sort of a global sort of server or a container or server, in a sense that all containers should be able to connect to the same container where Kafka is running. So this is, let's say, your REST API, and it wants to ensure that it's able to either write the data or read the data of this particular database in streaming sort of format. So this particular database, we have it here, and here you'll want to ensure that whatever data we have here, the connector, so part of the connector will be configured here. So this particular connector, which is sort of the client portion, it will be running inside this particular container. It will read the data of it, and it will basically make use of Kafka REST API concept, because Kafka does have its own API as well. It does let you connect to some remote Kafka server and so on. So this Kafka Connect will basically read the data and will write the data to the Kafka topic, which is hosted outside the container. And then this particular REST API will basically want to get the data of it as well. If you do want to make things very, very simple, well and good, do not use this global topic sort of concept. Just create the topic, or have Kafka set up inside the container and just write the messages to your topic in the same container, or the topic of the same container. You can choose to make things simple like this, but ideally we should have Kafka topics hosted outside the container. The reason is that in case if this container has crashed, then you might lose this data. And in that case, you will definitely want to make sure that you utilize Kubernetes or OpenShift or some other Kubernetes sort of solution to ensure that this container is sort of replicated. We have multiple copies of the container available and so on. Ideally, we should have the Kafka topic outside the containers in sort of a global sort of container, which should be available to all other services running in different containers and so on. Okay, so coming back to the demo, let me just quickly show you this one. After that, let's take a short break. After that, I'll talk about KSQL, Kafka streams by using KSQL and so on. Okay, so here I already have it up and running. Let me just move this window. Okay, so here we have the producer. It's a Spring Boot application, and here we have a command line based consumer right now. So here, the producer, right now it's a very simple consumer, but in the real world, definitely you will have fancy user interface, you will have a bunch of text boxes and so on. Like in case of order management system, you could have the text boxes for order details, etc. and so on. And when you click submit order button, it will send a message and save it to the Kafka topic. So right now, I'm just going to send the message like this. Let's say order number 1, whatever message you want to type in here. As soon as you type it in here and you send it to Kafka topic, which is managed by this broker, it will be consumed by the consumer right away. This consumer is a never-ending sort of application in a sense that it's just running and it's asynchronously processing the requests or the messages that end up in the Kafka topic. So there's no polling sort of concept here. It's all sort of based on notifications and so on. So a trigger results in execution of the code on the consumer side automatically. So basically here, Kafka heavily makes use of asynchronous coding style. So as soon as it ends up in the Kafka topic, it will be consumed. It will be picked up right away by your consumer and so on. And like I mentioned previously, in case of Kafka, it's a streaming-based concept. So it's getting streamed here. We can keep on adding more messages here. They will be picked up by your consumer right away in pretty much real time. And none of the messages will be deleted by default. So in case if you have multiple consumers, they will be able to process the exact same order or the request, etc. and so on. So they will be able to process the exact same details. You can choose to configure Kafka in such a way that it should delete the messages after they are processed, or you can choose to configure the expiration time, etc. if you want, and so on. In order to run Kafka, you have to make sure that you have Zookeeper, you have the broker or Kafka server itself, you have some producer and some subscriber. And again, it can be any type of producer. It can be a database server. It can be a web application. It can be a desktop application. Sky's the limit. Same goes for the destination as well. It can be any type of destination. It can be a database, SQL, or some web application, desktop application, command line application, etc. and so on. Okay, then let me look at a couple of more questions, then we will take a short break. Change data capture, definitely. In case if you're using SQL Server or other database products, they also support this change data capture concept, which means that as soon as or whatever changes have taken place at the database level, you want to keep track of those changes. But if let's say you talk about SQL Server CDC technique, change data capture technique, it does keep track of the delta, the changes which have taken place since the last time, but they are stored in a different table. And you have to query that table manually. So you'll not right away know whether things have changed or not. You could write a trigger if you want. Trigger could make a REST API. You could write a store procedure which could detect whether changes have happened at the database level or not, and then you could implement the streaming concept manually. But you're doing things way too manually, depending on the data source which you're using. You will have to implement the technique in that specific manner. You'll have to write too much code manually for that purpose and so on. Whereas if you use Kafka, it will be agnostic of these uh, sort of technologies and so on. It will be able to connect to the techniques because most of the work is already done by Kafka developers in that, or whoever has implemented Kafka, they have already done most of the work in the Kafka connectors, basically. So basically, it's an easy and lazy way of converting any technology to a streaming-based technology and so on. Um, Then, so DB2 support, you can search for Kafka connectors for DB2. You should be able to find for DB2. Otherwise, they're definitely available for Oracle, SQL Server, MySQL, DB2, even for NoSQL databases like MongoDB, etc., and so on. So definitely, I'm pretty positive DB2 is supported, but I could be wrong there since I don't really use DB2 too much. I mostly use SQL Server, Oracle, MySQL, DB2, Cosmos DB, DynamoDB, and AWS, etc. and so on. So definitely, it's a huge. There's a huge list of connectors available, and there's a high chance you should be able to find one for DB2 as well. Okay. Okay. Then let's take a break. After the break, I'll talk about how we can utilize the streaming concept in more detail. Like I'll show you the Confluent platform, which supports case equals, etc. and so on. So let's take about a 15-minute break. We'll resume at, let's say, 12:15 Eastern Time. Okay, let's continue. So before the break, we discussed some of the core concepts of Kafka, that it sits in between two systems, and you can use it for loosely coupling your systems, whatever two systems it's sitting in between. It can loosely couple them so that they don't have to be aware of each other's actual location, URLs, etc., and so on. So they just need to know Kafka, which will be sitting in between. So loosely coupling, that will be one benefit you'll get out of it. Another benefit you'll get out of it is reliability, or sort of durability or reliability. So the source or the producer can send a message to the Kafka topic, and the consumer, even if it's not available at that time, maybe the machine is down, network connection is not available, you can still relax that, okay, you have stored the message in the Kafka topic, and whenever the consumer will be available, it will be able to connect to the Kafka topic and process the requests and so on. You're able to configure or ensure that the system is more durable. Even if one of the parties is not available, it should still eventually work. And you can also benefit from this feature, uh, this loosely coupling feature, etc., and so on, because you will also be able to improve the scalability of the system as well. So it will be highly scalable. You can add multiple brokers uh, running on multiple machines, and it will ensure that it's a highly scalable solution. So even if you do not consider databases, the streaming of database concept, like change data capture sort of concept, that you can use it for the sake of streaming the data. You can convert Oracle SQL Server sort of databases to streamed sort of databases. But the moment things happen, uh, they will be available in the Kafka stream and or the Kafka topic, and the consumers will be able to process the changes, etc., and so on. These will still be the benefits. Your REST services, microservices architecture, will be loosely coupled. Uh, the services, they will not have to talk to each other directly anymore. It will become durable. Even if the system is not available for a very long period, it's still fine. Eventually, whenever it becomes available, it can still process a request and so on. So none of the requests will be lost, and it's a highly scalable system. And obviously, the streaming aspect is there as well. So you can convert any database to a streamed database. So change data capture sort of concept. Whatever the delta, the differences are there since the last time, they will be available to us and so on. And again, streaming will become available to us not just with the databases, but also with REST services, etc. as well. So it could be any type of system, and we will be able to convert it to a streaming platform. So these are the major benefits you get out of Kafka. So most messaging systems, they do help us in loosely coupling the systems, but often they lack in scalability. Like often you're not able to configure or install them on multiple machines, and ensure that if one goes down, then the other should become available and so on. So depending on what messaging system you're using, it might not be available to you, whereas Kafka does offer it. But pretty much no messaging solution, or a very few messaging solutions apart from Kafka, will let you use streaming concept. Kafka is the king or the queen when it comes to uh, converting any existing solution to a streaming sort of solution. Kafka is definitely very good to you. So talking about streaming, let's cover this in more detail. So previously we discussed that Kafka is like a messaging system, or sort of an enterprise service bus where you store the messages, you process them, and so on. Then you, after fulfilling the request, you save it back to the queue uh, or the service bus, and so on. Or in case of Kafka, it's saved in the topic. So you can think of Kafka as a messaging solution. You can think of Kafka as a database where you can store data. You can query the data. You can think of Kafka as a REST API sort of concept that it lets you loosely couple the producer and the consumer. So they don't have to know about each other at all. In between, they will have Kafka as the common thing, and they just need to connect to that Kafka. So the two services, the producer service and the subscriber service, they will never have to know each other's URL anymore. They just have to know Kafka topic, which will be sitting in between and so on. So definitely, Kafka can be thought of these things. But primarily, it's a streaming platform. Yes, it's helping us accomplish all the above things that we have discussed previously. But primarily, it's a streaming platform which offers these features as well. The streaming is the main benefit, basically. And again, streaming wise, keep in mind that by default, none of the messages are deleted. You can configure Kafka. You can say that as soon as it's processed, it should be deleted, or it should be deleted after certain time interval. You want to expire the messages. You can configure these things. And what it means is that by default, if you have multiple subscribers or consumers, they'll be able to connect to Kafka and they will be able to retrieve the entire list of messages in the Kafka topic in a streamed manner. So they will be able to stream it. And the easiest way to understand this streaming concept is that of, let's say, YouTube. So millions of users visit YouTube. They can go to the exact same video. And you play back that video, it always starts from the very beginning. So it's not that if one user has played half of that video, then the rest of the users will also be able to just view the remaining half of the video and so on. So they all have access to the whole thing. So they are able to replay the video. Likewise, in case of Kafka, you can replay the entire uh, topic, whatever messages items we have in the topic, they can all be replayed by all the subscribers and so on. So definitely it depends on your business case. Depending on that, you'll want to delete the messages automatically. In other cases, you'll want to keep the messages and just expire them after a certain time interval and so on. So Kafka is a very useful streaming platform, and it lets you connect any source to destination. It can be any type of application on the producer side. It can be any type of application on the subscriber side. So if you're in luck, you'll be able to find the connector. It will be available either out of the box, or you'll just have to search for it. There are third-party connectors available. Some of them are free of cost. Some of them you have to pay for, and you'll be able to use it with Kafka. In other cases where none of the connectors are useful to you, in that case, you do have to write the code manually. And streaming-wise, out of the box, Kafka already has the streaming ability. And in order to make use of the streaming concept, or make it even easier, you can choose to use KSQL. So KSQL makes querying of the data in a streamed manner easier. Without KSQL, you have to write the code either in Java. You can choose to use just the plain vanilla Java. You can choose to use Spring Boot. You can choose to use Node.js. You can use Python, .NET, etc. and so on. You can use pretty much any major language under the sun. And you can download the appropriate libraries or the dependencies or the packages, and you can make use of the Kafka API and just call various functions, etc. and so on to make things work, like send the messages to the Kafka topic or receive the message of the Kafka topic, or you can even create topics, delete messages, delete the topics, do whatever you want. So just like you use other libraries, let's say in case of Java, you use, let's say, JDBC sort of libraries to connect to your databases and so on. You have to basically know the functions, the classes, etc. and so on. So sure, you can do that. So if you are developers, well and good, use this technique. But in case if you want to use a relatively easier approach to query the data which we have in the Kafka topics, or whatever data is getting streamed, you want to view it in an easier manner, you can choose to use KSQL. The KSQL, it is SQL, the same SQL which we get to use with Oracle, SQL Server, DB2, etc., and so on. The same select statement with some minor differences, very minor differences. Uh, so, for example, if you have to retrieve top 10 records, depending on what database server you're using, you either say top 10 like this, whatever columns you want to specify, or in case of KSQL, we'll have to use select whatever columns you want from table name, in this case, it will be the topic name or stream actually, and then we could use limit keyword and specify how many items you want to retrieve and so on. So overall, it will look like regular SQL statement. You can use the select keyword from where you can use having clause, group by, etc., and so on. So most of the things that we get to use in regular SQL queries, we get to use them here as well. So you can query Kafka topics in a streamed manner with ease by using KSQL. So this way, you don't even, in most cases, you won't have to use too many classes and functions, etc., and so on that are part of a specific library for that specific technology. Like usually, in case of Spring Boot or Java, etc., you have to download the libraries, you have to go through all the classes, what functions are available, etc., and so on. And sure, you can do it that way if you want. Or you can say that, no, I want to just use the select statement. I'm aware of it. So I want to reduce the overall lines of code, which I would have to write to retrieve the data that is getting streamed and so on. So for that purpose, you can use KSQL, which simplifies the querying process. And unlike other databases, where usually when you run the select statement, that's it. You have to run the select statement again in future to hit the database and get the up-to-date data. Here, when you run a statement, it is streamed. So it will be a running query. I'll show you that practically in just a bit. So it will be a streamed or a sort of a running query and will keep on showing you the up-to-date data, etc., and so on. So it is asynchronous in nature. And the moment the data becomes available in the stream or the topic, it will be streamed and you'll be able to process it on your side and so on. So KSQL, in short, makes querying of Kafka topics easier by not memorizing too many classes and function names, etc. So it basically simplifies the overall querying process. And KSQL, out of the box, if you use Kafka, which is also basically called Apache Kafka, it's an open source project. Apache Kafka doesn't have KSQL out of the box. It has to be downloaded separately. It has to be configured separately, and it can be a very daunting process to connect KSQL to Apache Kafka. Sure, you can do it if you want. Otherwise, usually it's recommended to go for a pre-packaged solution which already contains KSQL along with Apache Kafka. And for that, we get to use Confluent Platform. Confluent Platform is not a new thing. It's actually developed by the same people who have written Apache Kafka code. So the same team has the open source flavor, which is Apache Kafka, and they also have this another option as well, which is Confluent Platform, which also actually comes in two flavors. One is open source and one is paid. So obviously in the paid flavor, they add more bells and whistles. So for example, out of the box Confluent Platform, it already contains the exact same Apache Kafka. The open source one, with, which you can easily download, install, and use, etc., and so on. And on top of it, it also contains KSQL, which is already pre-configured. It's already aware of this Apache Kafka. You can easily utilize KSQL along with Apache Kafka if you use Confluent Platform. On top of it, it contains more things. For example, it contains control center, which I'll show you practically in just a bit. It's basically the web user interface. Apache Kafka doesn't have any web user interface at all. It's all command line, it's all terminal based. But if you use Confluent Platform, it comes with this control center, which is a web user interface, which lets you do quite a few things, which you'll see in just a bit. And it also contains the registry, schema registry feature as well. In advanced scenarios, when the producer writes a message to a Kafka topic, you'll definitely want to say that it should have a certain format. Like if you're, let's say, storing data in JSON format, you could say that we have, let's say, product ID. That's one of the properties or sort of columns. It's sort of acting as a column. That's the ID. Then we have, let's say, product title. So sure, you can create a structure like this, whatever value you want here. So in the beginning, you will say that this is all we need. And you already have written the consumer as well and so on. In future, you will say that no, our requirement has changed. We need to modify this structure. We either need to add more properties or sort of columns here, or we need to rename one of them and so on. So how do you do that without breaking your existing consumers? So we want to make sure that things are backward compatible. So for that, a Confluent Platform offers the schema registry concept. It has lots of usages, and one of the usages is that it lets you version the schemas. So this way, the consumer would say that I always want to get version 1. And if you never change the code for consumer at all, it will always get version 1 of your schema, of your sort of the structure of the data which you have and so on. And the newer applications could say that we want to use version 2 of this particular schema, which contains more columns. Maybe the columns are renamed, etc., and so on. The schema registry allows you to sort of version the schemas, etc., and so on. This is a paid option. Control Center is a paid option. KSQL integration is a paid option. You can choose to install it separately, but even on the official Confluent website, Confluent team says that it's not really recommended to install KSQL manually with Apache Kafka. They recommend going for Confluent Platform because it's thoroughly tested with Confluent Platform. Without Confluent Platform, integration between Apache Kafka and KSQL is not really thoroughly tested. So basically, Confluent Platform is not a new thing. It contains Kafka. If you just want Kafka, well and good. You can use the open source flavor, well and good. But if you want to use these additional features, you have to go for Confluent Platform. So this is conceptually very much similar to, let's say, Kubernetes. In case of you guys have used Kubernetes in the past, which is a Docker container orchestration solution, which lets you manage multiple containers, etc., and so on. It offers load balancing, stuff like that, and so on. So Kubernetes, you can install it manually. And then you can use the command line tool, kubectl, and so on. But again, it doesn't have any user interface whatsoever. So that is why we often prefer using a pre-packaged solution, such as we have OpenShift. It's developed by Red Hat, or we have Minikube, which is provided by Google. But they both have user interface. They have lots of other features as well. They do contain Kubernetes, the open source Kubernetes as it is. And on top of it, they contain more features such as a web user interface is here, and lots of additional features are available as well. So Kubernetes is what you want to use, but often we go for a more enterprise solution like OpenShift or Minikube, which does contain Kubernetes out of the box. So likewise, in case of Kafka as well, you want to use Apache Kafka, but we like these other options. So in that case, when you go for Confluent Platform, it contains Apache Kafka as it is, and on top of it, it contains more features as well. So here, since we want to discuss KSQL, so I'm going to use Confluent Platform, and you will notice that overall it does contain the broker and Kafka or the Zookeeper, etc., and so on. But on top of it, it contains more features as well. Is a schema registry mandatory for KSQL? No. If you want to use KSQL only, schema registry is not mandatory. You can totally skip it if you want. So definitely, KSQL can be used without schema registry. Okay, so let's see how we can use a bit of KSQL here. So for that, I'm going to, let's say, switch to my different virtual machine here. And start the Confluent platform, which under the hood will start up Kafka, Zookeeper, Kafka. It will also start up the control center, which is the website or a web UI basically. And so now let me do a bit of homework here. Let me ensure that since I haven't really configured permissions for other users, so I'll just do everything as root for now. Otherwise, definitely you can configure things so that you don't have to do everything as root. And you don't have to use Linux if you don't want to. Right now, I'm using CentOS on my side, but you can definitely do it on Windows as well if you want. The Windows, Mac, Linux, they all support Kafka. Then let me do a bit of more homework here. I'll quickly disable sort of the firewall and some security sort of settings and so on. And let me also ensure that I have an IP address assigned to my VM or yes, this particular VM. Okay, so this has nothing to do with Kafka. I'm just doing it so that without configuring security, etc. and so on, we should be able to do everything. Then next, we need to start up various services like the Zookeeper, Broker, etc. And KSQL. KSQL is also a service. We also want to start up Control Center, the web user interface, and so on. For that, let me go to the folder where I have Kafka installed or Confluent installed. So Confluent start, it's a starting up Zookeeper. It takes about a minute or so to start up all the services. But under the hood, and even here, you can see that it's telling us that sure, you can use Confluent start, but use it for development only, just to be a bit lazy and just run everything automatically or with ease. But in a production environment, we should not do it like this. It's giving us a URL, and when you open up the URL, it will tell you that we should start up various services manually like this. So Zookeeper should be started up like this. This is the actual command. Broker, Kafka Broker should be started up like this. Schema Registry, if you need it, start it like this. If you want the web user interface, start up the control center like this. If you want to utilize various Kafka connectors, which in most cases you'll want to use, start up the connect service like this. If you want to use KSQL, start up KSQL like this. So these are the actual commands which should execute in the production environment. But in development environment, to be lazy, we can just run this Confluent start. It has started up Zookeeper, Kafka Broker is up and running. Next, it's starting up the Schema Registry, which we will not utilize in this particular uh, example. We just want to use KSQL. Kafka REST allows us to interact with the entire Confluent platform, including Kafka, by using REST APIs. You can write code in JavaScript. You can use jQuery. You can use Angular sort of code. You can use this regular REST API sort of coding style to connect to some Kafka broker and create topics, retrieve messages from the topics, do whatever you want, simply by using the REST API sort of concept. This is also something which is not available without Confluent platform. Without Confluent, we have to rely on uh, the libraries mostly. Like you have to see what classes are provided by that library, what functions are provided by that library, and so on. Whereas here, when you use Confluent Platform, you'll be able to use SQL statements to interact with the Kafka topics. You will be able to use the REST APIs to talk to the topics, get the values, etc., and so on. Next, it's starting up Kafka Connect service, which allows us to utilize various connectors. So when you run a connector, that is also known as a worker. So worker will be responsible for doing a certain thing. Like it will be responsible for connecting to some database server or some application server and keep on fetching the data and it will make sure that it's available in the Kafka stream so that it can be processed by the consumers and so on. So in just a bit, I'll use connector. Next, it's starting up KSQL server so that we can use the regular SQL statement, or to be more precise, it's called KSQL. So once all these services are running, I believe the next one will be control center. Once that is done, we'll be able to connect to the web user interface. Even though they're all up and running, but still it does take about a minute or so before the web user interface will become available to us. And let me actually not use Firefox. I have some issue in Firefox, but now I'll just use Chrome. And you can choose to do everything from the terminal if you want. Like you can use KSQL from the terminal, do everything from here. But if you do use the web user interface, it does make things a bit easier. Okay, so once the control center has started up, you'll be able to connect to it by using this default port number 9021. Okay, so here you can choose to check how many clusters are currently available, how many nodes are there in that cluster. And here you have to just keep on clicking try again, since I've just recently started up Confluent Platform, which means Kafka, Broker, Zookeeper, etc. and so on. So it's going to take a bit of time before it will show us the details properly. Let's go back to the home page. So this user interface is not available if you use the out-of-the-box Apache or just the plain vanilla Apache Kafka. So Confluent Platform, it's not a different thing compared to Kafka. It's just that it contains Kafka as it is, and on top of it, it also contains more features. So let's go back to clusters, verify that we are able to see the details here. So like I mentioned, after starting Confluent Platform, it still takes a few more minutes before services are really available to us. Say our goal is to utilize KSQL. Okay, so next let's create a topic here. So if you recall, we discussed that we can create topics to store messages and so on. Say I have a bunch of topics here from previous demos, sessions, and so on. I'll just create a new one from scratch here. So think of topic as sort of a queue, or in very simple terms, you can think of it as sort of a table in your database. Okay, so here I'm not going to bother with the partitions for now. I'm just going to name it. Let's say we want to store a bunch of employees. I want to create this topic. Now, in the real world, we should write some application in Java, Spring Boot, Node.js, .NET, Python, etc., and so on, which should write messages to this topic, employees. So this employees topic is available in our cluster. So any application which connects to this cluster will be able to utilize this employees topic, and it will be able to write the messages to it. So here in this very short session, we will not discuss how to write the code to write a bunch of messages to the topic. But here our assumption is that some application will write the messages uh, in this particular topic. So they will be available here, like the list of employees. They will keep on getting written to this employees. And here, I'm not going to write any code from scratch. Instead, I'm going to show you connector concept. So we do have lots of connectors. And one of the connectors allows us to generate sort of sample data in a topic so that we can experiment and play with this uh, overall Kafka concept and so on. So without writing even a single line of code, we can use various connectors. So let's add a connector. Here it will show us the connectors. Right now, I don't have any too many connectors available out of the box, but you can see that we do have some connectors available. For example, we have a connector which allows us to read data of any JSON sort of file or CSV sort of file, and we can bring it into our um, sort of topic, and we can stream it. So you can even query CSV file, JSON file by using this file stream concept. Or you can, let's say, use GMS in case if you want to get the data from GMS and you want to stream it. You want to use JDBC to stream data which you have in any database, etc., and so on. You can stream data by using some of these out-of-the-box connectors. Uh, to use more connectors, you will have to go to the official website, search for the connectors, or in other cases, you just have to search for just on Google and see if any third-party site has a connector for Confluent or this Kafka and so on. So here for now, I'm going to use data generator connector, which is a very simple connector which generates random or sample data. It will become available in our topic, and we will be able to stream it and so on. So like I mentioned, it's a very easy and lazy way of generating the data without writing any line of code and so on. But obviously, in the real world, you'll want to use a JDBC connector to connect to some database or GMS or some other like file connector, etc., and so on. So for now, I'm just going to use this data generator connector and just name it. Let's say I'll just name it data generator employee or employees. It's just a random name, whatever name you want to use. And then here we have to specify some more details. For example, the topic. So which topic you want to connect to. So we want to connect to, let's say, employees. And then you can specify interval as well, like how frequently you want to connect to that particular, or for now, ignore this interval. Here we also have this quick start. So quick start is sort of a template. So this data generator template, it supports various or provides various templates out of the box. Like what type of data you want to generate, what columns it should have. So there are some templates available. For example, we have a template called users. So this users generates about 4 or 5 columns like user ID, gender, department ID, region IDs. So they are columns like these basically. So they're generated automatically along with some random values and so on. So likewise, there are lots of other templates that are supported by this data generator. So here for now, I'm going to use this users, a quick start template. So it's going to generate a Kafka topic named employees. Okay, so on the left hand side of the control center, you can see KSQL option under development. Let's go to that. And here you can see KSQL editor. You can type in the query, but before we do that, let's create a stream. The stream basically connects to a topic of a Kafka broker. and let's stream that data. So for that we have to add a new stream. Let's select our topic which we want to stream. Let's select employees in our case. Then we have to specify the type of data which we want to utilize. So here we are going to use Avro for now. You can use JSON if you want. And then here we can see the default columns it will create. We can see the data type. Let's save the stream. So basically, once we are done with this part, we should be able to stream the data which we have in the topic. So we have the query here. Select start from employees. Click the run button, and it will basically start getting streamed. And before we click that, let's go back to streams. Notice that the stream that you created, it's showing up here as well, employees. Let's go back to the KSQL editor, click the run button, and here we should be able to see the data. It's getting streamed of that Kafka topic named employees. So this is going to be sort of refreshed in sort of almost real-time manner. Sure, there will be some sort of lag here, but the moment data shows up in a Kafka topic, it will get streamed, and we can see it here. And this is basically the live data. You can scroll through the data, and you will be able to see all the records here. So once we are done looking at the data, we can see all the columns here. You can see gender column. We have female, male, other values. So say that you want to add a filter. So say you want to write the where clause here. So where gender equals, let's say, female. So when you type in the query, and very importantly, you do have to make sure that you type in a semicolon at the end of the statement. Click run. It will show you the result here. Again, keep in mind that this is streamed. So once you run the query, it's sort of always running in the background. You do have to click the stop button if you don't want to get the data or have the data streamed anymore. You'll have to stop the data, or stop this particular query. And for now, we have been writing these queries in sort of ad hoc manner. They are not persistent queries in a sense that if you close this web browser, the query will be lost. So if you want to save this query, you want to make it more persistent. Just like in databases, we usually create views. They are the persistent queries. So likewise, here we can use create stream, then specify the stream name. So let's say we call it female employees, and then we have to use the as keyword. So overall, you can see that the syntax is pretty much like create view name as that we use in SQL queries and so on. So basically we have created a stream like this, and this is now a persistent query. When you click run, it will tell you that the query or the stream has been created. And you can actually go to the streams tab if you want. It will show up even there as well. And for now, if I just type in select star from the stream name which we just recently created, you can see that it shows up in the sort of IntelliSense sort of thing here. So select star from female employees. Again, this is basically getting streamed. It's connecting to the topic and getting the data in sort of real time. The data is getting streamed basically. So let's stop this particular query. You can see all the columns are available here, or it's up to you whether you want to stop the query right away or you just want to keep on getting more data or not. So once you are done viewing the data, you can choose to stop it. Then you can also choose to on the left hand side you can see that there are more details listed, and here you can go to this running queries tab. It will show you the queries which are currently running. So in case if some query is still running, if it's a sort of a streamed query, or so it will basically show up in the running queries tab, and you can choose to terminate the query from there if you want. And you can do something similar from the command prompt or the terminal as well. So just execute ksql. So if you don't want to use the Confluent Platform's control center, you can choose to
run KSQL from the terminal. It takes a bit of time to connect to KSQL server. Once it connects to it, you can run your queries. So let's say we query the or run this query again, which we saw previously. But actually, customers, we didn't create customers as part of this particular demo, but I do have customers available as a stream, or you can choose to query your stream, which we created as part of this demo earlier on. So select start from employees. It will show us the um, streaming sort of data here, and it will not end by itself. It will just keep on running. So once you're done, you can choose to exit out. You can now choose to stop Confluent Platform, which will stop all the services which we discussed previously, like the broker, Zookeeper, KSQL server, Schema Registry, etc. and so on. So basically, that's how we utilize some of the core concepts of KSQL.
So basically, we have discussed that Kafka allows us to loosely couple the systems. So this way, in between, you'll have Kafka involved, and it will make the producer and the subscriber sort of independent of each other. Oh, how to avoid duplicate. So a very good point. So here, just like in databases, etc., and so on, we can configure the constraints. So likewise, we have a similar concept here as well. We can say that certain column value should not be repeated and so on. So you can configure this concept here as well. Yes, in the Kafka message. So when you create the messages or when you create the overall structure, you can say that certain property value should not be repeated. And for this purpose, usually we have to utilize the schema concept. We have to say that this uh, column should have, or this property should have a unique value. So this way, if you try to enter a duplicate value, it will basically error out. Otherwise, by default, it does let you duplicate the values. Okay, so any further questions? So maximum size, etc. It there's no really any limitation as such. As long as you have sufficient storage resources available, you can definitely add as many as you want, or messages and topics, etc. You want. You do have to increase the number of brokers in order to ensure that you're able to create or support more number of topics and more number of messages per topic and so on. So most properties like database tables will be available here as well. So definitely there's a connector available for ELK. So you can connect to your Kafka topic, and then it will basically become available in your ELK, and then you can use the Kibana portion of ELK to visualize it on the screen. ELK definitely has a connector for it, or Kafka has a connector for ELK. Teradata, there's a connector available for Teradata as well. So in most cases, like I mentioned, you'll be able to find a connector either directly from Confluent or on the Kafka website. Otherwise, in other cases, you have to go to the third-party company that you want to support and see if they provide a connector. If you're out of luck, there's no connector available, the last option is to write your own custom code. So custom code-wise, you will have to basically connect to that third-party product, read the data, and then write it to your Kafka's topic and so on. Okay, so any further questions? And we will make the slides and the video recording available online. Okay. Okay. So thank you very much, guys. It was a pleasure to be here with you for this session.